Well, IceCube is fundamentally a science project, but there's a lot of engineering challenges. One of the biggest ones is making the holes in the ice. It's a 2,400 meter deep hole. It's big, it's about 24 inches in diameter, and the challenge is to try and do them quickly so that we don't use a lot of fuel. On the instrument side, there's some challenges in getting the timing and the electronics to read out a single photon. It's possible to do, but to do in production, to make 5,000 DOMs that all work and will work in the ice where you can't repair them is a real challenge.
Well, in high school they tell you that matter is made from neutrons, protons and electrons that make nuclei and atoms. In fact, that's not true. Matter is made from neutrons, protons, electrons and neutrinos. Neutrino occasionally crashes straight into an atom in ice, into a proton actually, it's hydrogen, protons. And then it produces particles, which is like a small nuclear reaction that happens, and it emits blue light. And so this blue light actually streams through the detector like the wake of a boat. And so we not only detect the light, we reconstruct the shape of this wake. And you know, another comparison is, if you see the wake, you know where the boat is going, even if you don't see the boat. So how do you detect light? There is a proven technique that was discovered before World War II, I think. The technique involves an instrument called a photomultiplier, which looks like a huge light bulb. It's 10 inches in our case. And when light strikes the light bulb, at the end of the light bulb, a little electric current comes out. That electric current is very feeble, but it tells you that light was produced. And then you have a system that amplifies this current and sends it over a wire to the surface and eventually to your computer. And so you can think as IceCube as a kilometer cube of ice watched by 4,800 of these light bulbs, and then their PC send messages to you, and the computer at the surface put these messages together and reconstruct the light pattern made by the neutrino.
This is a discovery machine, and the problem with defining how important it is that you really don't know what you're going to learn. There's a possibility that we'll learn something completely new by looking at the universe with neutrinos. That is the most exciting thing. You know, to get funding, you have to kind of discuss, well, maybe we'll see WIMPs, maybe we'll learn something about dark matter, maybe we'll find something in the universe that is producing these high energy neutrinos. Ultimately, we're looking in the sky in a new way, and the hope is that we'll find something that we really haven't even thought about asking, and that would be really exciting.
IceCube is a telescope, and it makes a picture of the universe using neutrinos instead of light.